So this is one of the most unusual questions that I have seen with respect to differentiation. As I mentioned, differentiation is not tricky at all. But the thing after the differentiation sometimes become tricky, like in this question. If you are good with trigonometric manipulations, then this question will not be that difficult. But if you are struggling with trigonometric manipulations, this is a question that you must try. The question is coming from Feb March 19, paper 3, variant 2, and this is the fifth question of the paper. We are given the variables x and y, which is satisfying the relation sin y is equal to tan x, where y lies in between minus pi by 2 and pi by 2. And we have to prove that the derivative of this equation comes out to this. Interesting thing to notice over here is in this equation there is a presence of y, but in the derivative there is no presence of y. It indicates that you will have to convert y in terms of x. And that was, I think, according to me, that this was the most challenging part for most of the students. But yeah, let's see how I will personally do this question. The first thing would be I'll differentiating both the sides with respect to x. So it will become d dx of sine y, and on the right hand side d dx of tan x. Now over here, differentiating on the left hand side with respect to x, but you're dealing with the y term. So after differentiating sine y, which is cos y, I will need to multiply it with dy dx. So it will become dy dx multiplied by cos y, and on the right hand side, the differentiation of tan x is sec square x. Now if I make dy dx the subject of formula, I just say that this implies dy dx is equal to sec square x, which is nothing but 1 by cos square x, multiplied with cos y. Now if you relate this with what you have to prove, most students are struggling over here only, that how can I go from this format to this format. So if you just compare, what are the things that we are already having? We are having the cos x over here. The cos y is supposed to be changed into the cos 2x format. Now for that, you should be able to derive a relationship between y and x. So let's try to do this. There are multiple ways in which you can do this, by the way, depending on your practice, how you have been doing in your trigonometry, coming from AS level, even in your A2. It depends on your practice, all right? So I'm going to show you just one technique that comes to my mind. You can surely use some other techniques, whatever suits you the best. Over here, what I can do is I know that my sin y is equal to tan x. Tan x is nothing but sin x over cos x. So I can just create a triangle and say that this is my y, and I know that sin y will be equal to opposite over hypotenuse. So tan x can be written as sin x over cos x. So sin x goes over here, cos x goes over here. So sin y is equal to what am I saying? Yeah, sin y is equal to sin x over cos x. That is what I'm able to understand. So if I want to derive a relationship of cos y with respect to x, I need to find what is my adjacent. So using my Pythagoras, I know that it is going to become square root of cos square x minus sin square x. And now I know that cos 2x is equal to cos square x minus sin square x. So I can just say that from here, this will imply, let me change the color to orange. And this will imply that my dy dx is equal to 1 by cos square x multiplied by square root of cos 2x. Oh wait, I forgot to find the value of the cos y. So from here I can say that my cos y is adjacent over hypotenuse. So that is square root of cos 2x over cos x. So that is how you will see that one of the cos x will get cancelled over here. Let me show it to you. It will be square root of cos 2x divided by cos x. So as I had mentioned, this one of the cos gets cancelled with this cos, and you are getting this format as we wanted. So therefore, my dy dx is equal to 1 by cos x times square root of cos 2x. Now let me know in the comments which method you have used to prove from here to here, which method did you use?